session. Good morning, everybody. Thank you so much for joining. This is another of our sessions with LLPA and Microsoft. This one is Practical Applications of Azure AI Services in Research, which is a huge subject, and I know a subject which is close to a lot of people's hearts. So I'm sure Mario will be able to give us a huge amount of insights into this, and I really look forward to hearing from him. So Mario, over to you.
Thank you very much, Carl. Okay, guys, greetings from Zagreb, Croatia, capital. Just a few sentences about me for those who doesn't know me already, because this is our fourth session, and I will just get back to it. So, Zagreb, Croatia, more than 16 years in IT industry, through the lots of different kinds of roles. Started as a full stack developer, solution architect, team lead, project manager, CTOs in different kinds of entities, etc., etc. But what's important for us today, I am really tight with Microsoft platform, with Microsoft technologies, and I have multiple certifications of Azure and AI in general, solution architect, AI engineer, etc., etc., etc. And obviously these days I'm focused on building up and combining these AI pieces of puzzles into digitalization and custom software development for different kinds of industries, different kinds of business processes, engineering, solution architecture, cloud consulting, lecturing. So yeah, let's move forward to our topic today. But before that, let's check what we talked about in our last couple of sessions, because this is our fourth session. We started in terms of analyzing of research data problem, of how to approach of consuming, understanding data, and which kind of technologies is offered in the Microsoft ecosystem regarding this. We went in the second session in the cloud infrastructure, talked about the Fabric, OneLake, Lakehouse, Medallion, data engineering, ML Flow, AI Foundry, Workbench, Model Catalog, AI agents in a perspective of European Union and whole regulations that are around Europe here, and some thoughts about the code interpreter. We saw some kind of demos regarding this. And after this, what are we going to talk about? Today we are going to broaden our perspective. We're going to talk about the additional stuff in the Azure ecosystem, in the Microsoft ecosystem, which are related to the data, which are related to some kind of cognitive capabilities of understanding and do some kind of nice stuff with this data, text analytics, knowledge mining, and document processing. By me, we are going to talk about services landscape, text analytics. We are going to check in different kinds of demos, starting with the first one with language services of the text analysis. After that, we're going to switch to the knowledge mining concepts, and we're going to see what kind of opportunities, what kind of products do we have in Azure ecosystem. In terms of that, we're going to talk about Azure AI search and how to connect different kinds of categories of data and different kinds of types of data to it, indexed and stuff like this. Document intelligence, document processing. We are going to do just a glimpse over the Cognitive Studio, have some kind of demo over here so you can have a feel what you can do and how can you easily leverage from some kind of pre-existing models, or how can you use pre-built or custom models of the content understanding in the documents, multimodal AI, and some kind of broader perspective architectures and next steps. That's our agenda for today and these 2 hours. There is not much of us today, so feel free to jump in with any kind of questions that you have. Maybe you guys have experience working with Azure in general, or with Microsoft tools and some kind of problems, issues that you have right now. So feel free to address it. Let's try to exchange the experiences. Let's try to be smarter after these 2 hours. Okay. So it's a beautiful thing to talk about AI. It's a beautiful thing to have a really great landscape in terms of different kinds of tools that are using AI, but using multiple different kinds of tools without kind of structure can lead us in some kind of mess. In terms of operative mess in terms of separation of concerns and responsibilities among our team, governance, even some kind of exchanging between the institutions, etc., etc., etc. So today landscape of AI tools, it's really, really, really large, and it's going to be larger with these advancements in technology. The idea to this today's lecture is to combine all these pieces of puzzles from the previous sessions and give you some kind of missing pieces, filling the gaps in it with the new technologies, and trying to figure it out in a broader architecture. How can this all fit in? So researchers are using AI without integration, validation, reproducibility. We are talking about reading cases of reading abstracts manually. Took weeks of coding, hand coding survey, sentiment across different kinds of languages, keyword only search, missing related documents, manual data entry from scanned reports, sharing transcripts without PII checks. We talked about the PII, that's important stuff from the perspective of security and governance, photo cataloging one by one. So idea, I'm going to show you today few technologies in Azure landscape that can help you achieve this in the seconds, and they can be integrated with all this nice stuff that we talked about it in our last sessions. So output is some kind of structured JSON, which is reproducible, auditable, loadable into Fabric, for instance, for the further processing, for some kind of auditing reasons, for the later integrations, etc., etc., etc. Azure AI services landscape for research. Let's talk about it. What is here and what can be used for our needs. When we're talking about AI, we need to talk about some kind of AI capabilities. We already mentioned that. Let's just separate this in different kinds of categories. For language understanding and interpretation, we have support for operations like text analytics, sentiment PAI. For the vision, we have image analysis, OCR, optical character recognition, object detection. We have content understanding, multimodal extraction, where we're talking about content understanding, not just extracting the text, but it's important to understand the intent, context of this data which we extracted. AI search, full text vector search, we're going to stay for a while on this kind of technology because it's important for all those systems that are AI using for some kind of knowledge retrieval. Document intelligence, structured extraction, and you can use this with just single multi-service resource. By mean integrating, remember from the previous sessions that most of those technologies are highly integratable via some kind of APIs, but some kind of REST endpoints, which you can then integrate into your workloads. So you have multiple deployment options from the different kinds of stuff, but in general, you need to understand that you can communicate with lots of those services via just pure endpoint and some kind of authorization key, or if you're talking about some kind of other aspects of security, Entra ID. I will not go in depth right now, but you can imagine that this is really secure. Deployment options for researchers. We have Foundry Hub. We did last time talk about Azure AI Foundry. Foundry in general, where you have lots of opportunities to consume some kind of models, pre-trained models, fine-tuned models, and you can even integrate these services that we're going to talk about today as a part of Foundry project, which is a cool stuff for the management organization perspective and permissions perspective. You can deploy it as a part of it. It's a single billing then in terms of that. Multi-service resource, you can deploy it as a single instance in Azure, which is multi-service, and you have lots of compatibilities. It's a one resource, one particular endpoint, and you have all compatibilities. And you can deploy it as individual resources. If you need only language, you can provision only language service. If you need content understanding, only content understanding, etc., etc., etc. Those are separate services, fine-grained control. And what is important here, it really depends on your workloads. You have different kinds of options. It's going to be less abstract in the next couple of slides. Pre-built custom models. Azure AI services have some kind of pre-built models. What does it mean? Microsoft pre-trained models for us, and we have opportunity to use them. We can, on top of these models, do some kind of additional training, do some kind of custom models. But from the Azure AI services, that means that we have structured output JSON, important stuff for integration. You can imagine, you will see in some kind of demos later. For instance, maybe you will want to push some kind of PDF file and want to extract the data knowledge from it. You have every single time guaranteed from these endpoints that it will be in a same JSON output. It will be deterministic, same in out, no prompt engineering. It's per paper API call pricing, and it's best for classification extraction. On the other hand, you saw in the session 3, Azure AI Foundry. The main thing that needs to cross your mind when you're talking about Azure AI Foundry is ability for you to provision some kind of more complex, more advanced solutions like large language models. Or we talked about it, more than 11,000 different kinds of models which you can provision and you can then access it. It's a free text output. It's probabilistic. Prompt engineering is essential. You're paying per token. It's best for generation reasoning. So remember, our all talking is about artificial intelligence. It's not just synonym for large language models, ChatGPT, Claude, or whatever you want to think of. It's a much broader aspect. So you need to distinct those two by compatibilities. Use cases. Why do you want to use any of this? This is something that is just, mentioned, some kind of brainstorming from my side in preparation, but I'm sure that you can figure it out from your perspective. Why do you want to use some kind of artificial intelligence capabilities in terms of sentiment analysis? Maybe for survey responses, you have opportunity to do sentiment answers, key extraction of key phrases, PII detection by some kind of confidential data, personal information data, language detection. On the other hand, we have document archives. Maybe you have really large knowledge base of some kind of research documents, of some kind of archives, libraries in digital format or whatever, and you want this to be really quick, accessible, and queryable, which is important today. Not queryable just by some kind of exact phrase, how we learned from from transactional databases or stuff like this. You can just, with some kind of technologies that you will see, query by similar phrases. We are in the domain of vector databases and some kind of other statistical stuff. You have opportunity to apply skills in transforming some kind of digitalized data by mean PDFs or TXT files or whatever that is, that will then transform and enrich this into the vector databases and prepare for to be queryable and prepare to be really useful for the end users. With semantic ranking, vector search has been said, you will see it. Lab reports, maybe you have lots of different kinds of lab reports in different kinds of formats. You need to read some kind of field notes, extract fields. You want to build some kind of custom analyzers of those lab reports and do some kind of summarization of it and store it in the archive or pass to some further processing, outputting to Fabric maybe for some kind of storing and visualization, doing dashboards, etc., etc. You can do lots of stuff with Azure AI services, as we are going to see. Single endpoint deployment, what does it mean? As we said, one resource provides access to all services. It's a single endpoint URL, API key, consistent authentication model, EU data resistancy, deployed wherever you want to deploy it. Important stuff, remember that we are in some kind of governance laws and stuff like this. It's important that we are assured that our data is not going to be leaked outside of the borders or whatever that governance on top of our university or organization is. You are the one who's choosing this, where this endpoint is going to be deployed. You have pre-configured models which are ready to consume, as we are going to see today in the session, or you can do some kind of modifications in terms of retraining those predefined models with some kind of edge cases or some kind of custom data that you have. Whole platform enables you to do that. Features fall into two categories: pre-configured, learned features. So pre-configured features can be used without labeling or training. Summarization, named entity recognition, PAI detection, key phrase detection, sentiment analysis, language detection. On the other hand, we have learned features that require labeling, training, deploying to utilize, conversational language understanding, custom named entity recognition, custom text classification, question answering, lots of different kinds of features. Once when you have this resource in Azure deployed, let's say to West Europe or whatever, you need to access it. And you can access it via HTTP call. It's a REST endpoint, which means that you can easily then include it into your workloads in Jupyter Notebook or in some kind of other processes, or maybe directly from some kind of other Azure resource. It looks like this, you know, you have some kind of endpoint, you have feature, what you want to do on language analyze text, what kind of semantic analysis. You will see the lots of different kinds of available features, and you're doing some kind of reference to documents. You will see how this thing is then processing. Data residency for AI services. From the perspective of Europe, you have different kinds of options. West Europe, France Central, Sweden Central. What does it mean that data stays in European data boundary? It will not go to the USA, it will not go anywhere further. You're the one who is in control of this. Sorry, no cross-border processing. You are completely aligned with GDPR. Ethics board can approve further stuff without some kind of transfers of concerns. Sorry, I was muted. Sorry. Thank you, Carl. Sentiment analysis for research in general. Let's talk about sentiment analysis, what it is. You can imagine that we have lots of informations, and these informations are not just you need to read it, you need to understand the context of it, so you can then evaluate it and give some kind of end evaluation in terms of, is it positive, is it negative, is it neutral. Why is this important? Because you can then on top of this do some kind of further analysis or do some kind of actions. I will give you an example from the perspective of retail industry of the web shop. So you can imagine all of you are probably doing some kind of shoppings through the web shops. You can think of the Amazon, which has under the products lots of the different kinds of comments of the products. And you can think of the Amazon as a global big web shop, and they have millions and millions of comments every single day. So idea is not to read this as a human and try to understand if the customer feedback was positive or negative in general of this product. They have integrated some kind of automatic AI that can detect on a massive amount of comments, is this product good or bad? Why they don't want to keep the bad product on their web shop at all. The same thing applies with maybe your cases like surveys or whatever you are dealing with, any kind of feedback documents. You need to understand, is it positive, negative, so you can decide. You have opportunity to do it easily with the services, document, sentence level sentiment, positive, negative, neutral, mixed with scores, opinion mining, survey responses at scale. So we are not talking about few, 5, 3 comments. We are talking about large scales of data, comparing across demographic groups, different kinds of analysis, all the way to one service. So this is some kind of output that it comes out. You have a reference, so it's scoring overall document sentiment, individual sentence. You have here, for instance, that on this particular some kind of dummy document that was processed, the output was that sentences are natural, sentences include positive and natural are positive in general when you're calculating this, negative, mixed. So important stuff for you to understand is that you have structured JSON, okay, which has lots of data, descriptions, scoring in terms of the confidence, and you can rely on this in your workloads. When you have this kind of document or many documents, you want to be able maybe as well to extract some kind of key phrases, main talking points per document. Maybe you have document of 100 pages and you want to just automatically extract some kind of key points. What are this document is all about? Is this something that is relevant for me or it's not? I can then categorize those by the key phrases, by some kind of clustering and stuff like this. Automatic topic tagging for co-occurrence networks replaces weeks of qualitative coding. You have all built in and easily for integration further. So you can use pre-configured features, language detection, key phrase, sentiment, named entity, entity linking, summarization, PAI, all those stuff. After that, named entity recognition. What does it mean? You can understand from the document, either is a document talking about the person, where this person is detected in the document, location, organization, data, and quantity. You can link directly to Wikipedia for some kind of broader context of understanding. Why is this important? Maybe you have public knowledge and you want to understand from the certain document what kind of broader entities, some kind of general knowledge entities are linked to this particular document. You can build up knowledge graphs from the literature. you can imagine knowledge graph like some kind of relations between the named entities. So if you have, let's talk about the novels, for instance. You have some kind of characters in the novels, you have some kind of story, and you have some kind of relations between those novels. Those models in the background can build up, can identify the important entities and relations between those, which is really important. Moving to abstract stuff, moving to some kind of science and research, this will in the real world are not some kind of fictional characters. We are talking maybe about some kind of physics, chemistry, or whatever we are in the researching. PII detection. We are processing the data, we are processing the documents, and we are, from those documents, are able to understand names, phones, emails, IDs. Why is this important? Because due to the regulations of the European Union and in general, not just European Union, we need to treat this kind of data special carefully. We need to mask this. We need to maybe exclude this from our researching, maybe to exclude this for further processing. This is why we need in some kind of working with the data on the large scale, do this automatically. We have the technology here which enables us to do that. And we have obviously some kind of outputs like category confidence, character offset, it's redacted text output available. This is important for the GDPRs and for the ethic boards documentations. So powerful stuff, you will see it in action. Custom text classification. If you're not happy with predefined possibilities, features, you can always bring your own some kind of training data, and you can fine tune and retrain those pre-built models in a background with your additional examples, with your additional data. You have documentation in which format that needs to be done. All this training is happening on the Microsoft infrastructure. So you don't need to have your, data center and invest in NVIDIA's or whatever you're just thinking of. So you can customize this kind of stuff and fine tune the models and this whole classification to your own need. So single multi-label classification, either we're talking about chemical compounds, gene names. You can imagine from your daily work what kind of scenarios would fit you the best. Moving forward, Azure AI search. What's that? Imagine that we have lots of data has been explained. Some maybe some kind of archive, maybe some kind of library that is not just archive which is using, and we have some kind of organization of this data in terms of some kind of folders, subfolders, etc., for people to know where to search for related stuff. Let's jump forward and let's enable with this technology to the people that we are going to index all this data, and we're going to enable to the end users to query this data just by typing some kind of phrases. Azure AI search is giving us opportunity to do this. So reducing all this manual searching, all this manual reading, understanding of every single document, we can have this middle layer, which enables us to index this and enable us then to query it and to understand all this data. So it's a cloud search for document collections. It's enabling you full text, facets, filters, scoring, AI enrichment during indexing. What does it mean? Maybe you have data with some kind of images or tables or whatever. You can, in the process of indexing, integrate AI, which is going to read this, understand this by the rules that you want to be applied, and the result is going to be indexed with the reference to original data. This allows you to query after that, even by these kind of terms, semantic ranking, vector search with embeddings. So this is the full managed platform, and I'm going to show you how this thing looks like. So from this perspective, we have source, indexer, we have some kind of, let's say, this data source we want to index, whole process of indexing with enrichment, and all this, if you remember the ETL process, you can, from the Fabric, or this is the similar approach, just in terms of the indexing and preparing data for the semantic querying afterwards. We are going to check it in a demo. Okay, when we're talking about language detection, we are talking about detecting language, more than 100 different kinds of languages, including Dutch, German, French. Why does this matter? Maybe you inherited some kind of big repository of different kinds of research data, and you want to classify and you want to go, just move it from and prepare it to the different kinds of language, different kinds of language categories, and you have opportunity to do it through the Azure resources, pre-processing before the other analysis. Maybe you want to translate everything, detect and translate to some kind of common language of your research institution. So you can sort it, surveys by the language, all this nasty stuff that you probably did manually, you can do it automatically. So how does text analytics, some kind of pipeline can look like? You can have abstract, some kind of batch of the data abstracts, PDFs or whatever. You can then do some kind of language detection by understanding document by document, or maybe pieces of documents, in which kind of languages is this written. You can then, after that, have some kind of semantic analysis and extracting of the phrases and entities, detecting of the PII, and after that you can store the results of it in a Fabric Lakehouse. So just this is just some kind of reminding ourselves that we are not just tied to this particular services. We are going back to the previous session, so you can just feel the glimpse of integration and everything that you're going to talk about it later as well. Okay. Do we have any kind of questions before we move to demo? You're all good? Okay, let's then just move to the demo, and I will just switch here. And let us go to, just give me a sec, to the text analysis. So here is our portal, which is called Language Studio. You can see the URL up there. You can access it like this. And to communicate, this is just some kind of UI that gives you opportunity to communicate with the provision stuff, which is in the Azure. It's pre-provisioned. Let me just show you how this thing looks like. So we have here one language service, which was pre-provisioned before our session. Okay. There is not much to see here. You need to understand that behind this is this all those nice models and all those nice features that I'm going to show you right now, accessible via API. And this portal is just giving us opportunity to do lots of the stuff here, even to, create some kind of project. So once when you enter the language studio, you have lots of the options to do. Let's just check the stuff that we just talked about during the morning. We have extract PII, extract key phrases. We're talking about the group of the features from the extracting information, find linked entities, extract named entities, extract health information, custom name entity recognition. All those stuff can be done from this perspective. We can classify text, do some kind of sentiment analysis, detecting language, custom classification. We have opportunity to do some kind of understanding questions and conversational language by answering questions, custom question answering, conversational language understanding, orchestration workflow. So obviously we have only 2 hours right now, but it's important stuff for you right now to take away is that this portal is available, and you have once when you are start to play with it, lots of the learning resources to get into depth and to understand the all features in the more details. We have opportunity to summarize some kind of information. You understand this from the perspective of ChatGPT or whatever you're using, that you maybe have 25 pages of information and you just want to summarize and want to understand what is it in just few sentences and translation. Okay, from the perspective of our first session, we are going to navigate to the classifier of text. Okay, and we are going to do some kind of sentiment and mind opinions. Let's click here, and we have opportunity to play around with it. So what I did here, I selected the language of the text that I'm going to type here. We can, do some kind of examples. We can drag and drop some kind of TXT files for the purpose of this playground. And what is important, we have reference here to our to our language service in the background. What this portal is going to do is just going to serve us as an UI for communication with the language services in the background. So let me just go to some kind of dummy data that I prepared. We have it here. And let's just check this data. What is it? Okay. So this is the statement. Long-term monitoring, grind data, reveals significant improvements, blah, blah, blah. Our study of the 12 monitoring stations across Netherlands shows consistent. So you can understand this is some kind of dummy text, which we can then just use it. Just give me a sec, because okay, let's paste it here. We have English, and we can then run. What would happen in the background? We consumed the semantic model and got some kind of results. Results are like this. We got complete JSON of the confidence score, sentences, and some kind of is positive, neutral, or negative. So this portal gives us opportunity just to visualize this JSON nicely and to break it down. So it breaks down, first sentence, long-term monitoring. Since the implementation, your water framework directive, it's neutral, 85%, 15% positive. Sentence 2, 3, same thing as the sentence 1 in terms of the outcome. Our study of the 12 monitoring stations across the Netherlands show consistent upward trend with mean increasing from 2 between 2000 and 2024, sentence 3, etc., etc., etc. So I believe that you understand the idea here. We can just check the example of some kind of negative. Let's try to play around with this. Despite regulatory efforts, nitrate concentrations in agricultural drainage channels above EU thresholds, etc., etc., etc. Let's try to evaluate this and check what is happening here. So the first sentence is analyzed like mostly natural. Second as well. Third as well. Okay. So this is some kind of evaluation that you can get directly from the sentiment analysis. Again, repeating the output is in a JSON, which can then be integrated and then can be processed further, consumed, and built in different kinds of workflows. Okay. Let's now jump to the to understand how to extract some kind of key phrases, extract informations. Let's jump here and let's go with our some kind of example. Let's do this and let's try to see what are we going to do with key phrases extraction. So it's just evaluates unstructured text, return a list of key phrases. Its capability is useful for you to quickly identify the main points of your text, the same text as before. Let's check what are we going to find here. Again, JSON is something that was outputted, and this is just some kind of nice UI look and feel of it. So we have different kinds of key phrases that were extracted, and the AI extracted, regulatory efforts, nitrate concentration. This is just some kind of, visualization of it. So those are dummy examples, but you can imagine that those texts can be really, really large and hard to investigate manually. And you can have petabytes of those kinds of texts and data, and you will not do it manually. You have opportunity to do it from this perspective. Let's check from the other aspect, which is called named entities. Let's extract the named entities. Okay, let us just check here and try to analyze with a different feature. So it's just shortage NER. Entities in text, categorize them in the predefined classes, types as a person, location, event, product, organization. Okay, let's run it against this text. And this text was, categorized in different kinds of types, location, grind delta, confidence 99%. We have some kind of data, we have quantity, we have location again, etc., etc., etc. So you can understand why is this useful stuff, because you can again quickly do really, really, really nice analysis of the text and collect the data for the future, some kind of analysis, processing, and stuff. Let's jump to another feature of our language services. It's PII. Here we are, extract PII. Let's do another example. PII, just a sec. Let's just read the text. So what's the meaning behind this? Is to identify sensitive personal identifiable information. This shortage stands for. In terms of categorizing this in the predefined classes and the types. So let's check some few sentences. We have new water quality monitoring equipment from this, let's say, institution. Excellent Dr. Jan van der Berg from university help us to set it up. You can reach him on this mail, this phone number. Calibration process was frustrating, but data quality is much better right now. Let's run this. And what we got here, obviously, the JSON, which gives us some kind of text category and some kind of offset and length in terms of the whole positioning in the text, and confidence score. What is it? So we understood that we have here some kind of organization. We have person, again, organization, we have email, we have phone number, we have date time. Why is this important? Because right now, when you have this knowledge that you have personal information in the text, you can decide what to do with it. You can mask it. You can remove it from the text. This is something that you are obligated to, because in lots of the workloads, you are not allowed to use this data for retraining of your models or whatever. So it's important to understand which is person identifiers and which are not. But you can do this on a large scale of data, and you have opportunity to do it automatically and pretty much easily. Okay. So let's jump back to our presentation and just recap what we saw. We saw multiple different kinds of abstracts, some kind of statements, dummy statements, some kind of surveys, responses with the PII, some multiple documents, and with the technology which is provisioned in the Azure language services, we extracted key phrases, entities, sentiments, scores per sentence, PII detected, and all this in just few milliseconds, fully automatically. Implications, again, talking about scale thousands of docs in the minutes. You can imagine that you can automate this. Again, saying you can unstructured to structured data. When you're talking about unstructured, we're talking about the text which is unstructured. It's not in a relational databases or stuff like this. And you have something that you can contribute in compliance and everything. Okay. Before moving forward on the knowledge mining, do you have guys any kind of questions so far?
Thanks, Mario. I was just thinking whilst you were talking about that, about putting essentially loads and loads of election manifestos of all of the various parties on there, and actually doing a bit of a deep analysis of things like the sentiment and so on in those. That would be something which would be really quite fascinating to do. And obviously what this is doing is it's taking a defined set of data, so that you actually, when you're getting responses, you're getting responses based on your data, not just random stuff online.
Yeah, completely. And you need to think when we're talking about again, repeating, you need to think about this piece of just some kind of piece of the puzzle in your general workloads. This is something that will help you on the just one tiny path of your journey, and you think of the whole workload, what you're doing with the data and what you want to achieve with it, and this can definitely help you on this complete journey. Moving forward, knowledge mining, what is it? What is Azure AI search, and how can this help us? Let's check this. Already been mentioned before as a part of the language services. Why? Because language services are something that can enrich our data on the processing of the Azure AI search. But what is Azure AI search? It's some kind of cloud search. It's a fully managed service which can help us to index and search document collections. Those documents, again, can be some kind of archives, some kind of knowledge resources, etc., etc. We have full text, faces, filter scoring, built-in features for this, semantic ranking beyond keywords, vector search with embeddings. All this is supported in it. In general, you need to be some kind of familiar with a few terms here. I'm going to introduce it smoothly. We have indexer, which is the process which extracts the data from the data source. This data source, I will show you in our example, can be from the different kinds of sources. In our demo, it's going to be from the storage, Azure Blob Storage. Document cracking retrieves the text content from the source. After that, we have some kind of enrichment pipeline, which iteratively builds JSON representation, metadata about this data of yours, or for each document. This enrichment pipeline can then be connected to the language services or whatever that needs to be for you to have maybe better understanding of your data. You have for each field, for each document, some kind of fields that can be extracted from the source: file name, date, size. You have inferred generated in an enrichment pipeline, and the result of all this process is index. It's just some kind of file. We will search through the index in our demo, which has reference, which has all the metadata necessary and prepared for the Azure AI Search database for querying. That's important stuff. Indexer pipeline has been mentioned. We have different kinds of possible sources like Blob, SQL, Cosmos DB, SharePoint, with some kind of possibilities of document cracking, PDF, words, images. So you're not, how to say, you're not limited only to TXT, CSV files or something like that. You can push in it complex unstructured data, real data, which are we using in everyday work, images, PDF, words, PowerPoint presentations, whatever that is. After that, through this pipeline, we are doing this kind of cracking and stuff like this. We are enriching it with the AI skills. One of these AI skills can be language understanding that we just saw previously. And we have index, which is searchable store. We are then having this fully available, fully queryable store that I'm going to show you, which is then serving us for the better and easily searching of our data. Okay. We have built-in skills, for instance, detecting language of the text written in, extracting places, locations, other entities, key phrases, translating text, identifying, extracting, removing PII, extracting text from images, really cool stuff, generating captions, tags to describe images. Imagine that you have archive with millions of different kinds of images and you want to categorize those. You want to build up some kind of catalog. You can do it with this and build up some kind of layer that can serve you as a searchable layer. Custom skills, implement custom logic to return fields based on input, some kind of wrappers around services like Azure Document Intelligence, etc., etc. With this built-in skills, you have opportunity to bring your own custom AI skills. What does it mean? You can build up some kind of process, or you have some kind of your own model, which is hosted somewhere and it's reachable through the API. You can integrate it into pipeline, into ingestion pipeline, into this indexer. So you have opportunity to build up, to bring your own machine learning model or whatever you want to do with the data that is going to be processed and categorized is in a index. So language detection, key phrases, entity recognition, image analysis, OCR. So you can do all of this. And on top of this, once when you process the document, you are storing projections to the files you analyzed in storage, which serves to the indexer as some kind of good reference and some kind of helping in searching of executing of the queries. So those objects are JSON documents. You can store some kind of relational schema for extracted fields in tables, files, etc. Few more sentences about the projections. Those projections, once when you understand the text, this file, let's say it's PDF, can persist in Azure storage. You have structured data in a table projections, object projections in a blob, in a JSON format. You can build up structured database from the entities, and you can feed this whole metadata into Fabric, into your one lake for the further processing and understanding and whatever your workload is. Okay. So we are identifying entities that are mentioned in the text. You saw in the last example how easy that is with the services that we have in the Azure. We have entities are grouped in the categories and subcategories. You saw that, for instance, we can do categorization of the person, location, date, time, address, email, URL, and then we can have collection of more than one or documents in the request, and the response is going to give us confidence score, category, etc., etc., etc. from those projections. Semantic ranking, vector search. Let's move forward. Once when we have everything indexed, once when we have really nice and rich data, we want to do something with it. And we are going to then use certain capabilities of this Azure AI search. Semantic ranking, we are re-ranking results by query intent. What does it mean? We have technology, we have some kind of neural network in the background. If we query by some kind of intent and term, this layer is going to understand our intent and is going to understand the contents of our index. And by this intent is going to re-rank the query results to us, which gives us opportunity to query the data by our natural language. This is how these RAG concepts are in general working, Language model scores relevance, nitrogen finds eutrophication and stuff like this. On the other hand, you probably heard about maybe using vector search, which is doing some kind of, I would say, full text and fuzzy search among the different kinds of data. We are treating documents as embeddings. What our embeddings are, we are transforming the images or text or whatever into array of integers. So it's not in some kind of matrices. This is not readable to our humans, but databases are built really, really, really good in terms of after transforming this data into embeddings, matching our query, which is transformed in embeddings as well. And they're doing some kind of calculation of similarity and bringing back the most similar concept, more similar intent, let's say like the keywords, which is then transformed to the pure text, which is readable for us humans. So English query can find Dutch docs because we stored the universal language, mathematical model of the data. Let's call it like that. That's cool stuff. Being said, those vector databases are being used in a RAG. We covered in a session 3 RAG. What is RAG? It's some kind of knowledge base, and it's giving us opportunity to ground the large language models with our personal knowledge, with our institution knowledge, and gives opportunity that large language models are aware of this and can answer to our questions regarding the data which is not available on internet, or it's not been publicly available for training these foundational models. Documents are chunked, embedded during indexing, query embedded in the search time. AI search, this whole managed instance, is able to find relevant chunks. Chunks are passed to the LLMs as a context, and LLM answers with citations. So Azure AI search gives opportunity to such systems, to the agentic systems, to be grounded with this AI search, with this knowledge base. Same index serves agents, notebooks, web apps. Querying our archive, we are able, with this kind of stuff, already been said, do natural language and structure queries, filter by year, institution, method, face navigation, auto library catalog, do semantic queries. And what's important stuff, we can automate this rebuilding of the index, schedule it to be every few minutes or once per day, whatever our frequency about the new data or updating data on the data source is. Let's just think about the search in our workflow. We have some kind of document archive. On top of that, we are building AI search plus skills. We are building index plus knowledge store, and we are exposing some kind of search API, which is then available to the Fabric Lakehouse as additional data source, maybe with some kind of unstructured data, maybe with some kind of data warehouse that we have, and we can build up the beautiful AI agents, dashboards in the Power BI, whatever that is. Let's remove this abstraction, and I'm going to show you how this thing is working in real life. Okay, let us jump now to our Azure resources, and let us jump to pre-provision Azure AI search resource. Once when you provision this is how user interface looks like. We are not going to tackle through all options that you can use here, but from our perspective, we are going to just query some kind of existing index. So how to create general index, you have lots of options. Let's just go to here. Remember that we have lots of options of the choosing of the data source from the blob storage, lake storage, Cosmos DB, one lake table, SQL database. Okay, we can do lots of the stuff here, ingestion for the keyword search, which we did, and we are going to show it how this thing looks like. RAG or multimodal RAG. Multimodal means that we are going to index even the images or some kind of complex data, and we need to have some kind of additional models that can help us here. Okay. Once when you choose this, you need to have provisioned, data source, which we already created. Data needs to be stored in some kind of container, and you can do some additional querying, etc., here. Not to go through the whole process, this indexer has been created. Let me show it to you. And the data has been indexed. Once when you create the indexer, you have opportunity, to configure it, to schedule it or whatever, and to see the success of execution of it. Indexer in general looks like this. It's JSON, and you can check the format and the documentation. Man, this portal is only giving you opportunity to more easily understand what is happening over here. But what we did, we connected to the data source, which is our blob storage. We have some kind of, target index name, which the data is going to be stored. this can be pretty, complex. Remember that we can do on this indexing process lots of the different kinds of stuff. We can extract we can add some kind of additional skills. We can do lots of stuff around it, And this is just a simple one, but you can understand the glimpse of it. Our indexer was, executed only once. We can set it up different kinds of configuration over here in general, but the product of this indexer is this index. Let's jump to the index. Our index is configured like this. We have different kinds of fields. Those fields have different kinds of types and different kinds of capabilities by this. What was indexed is the data. Let me just show you. Some kind of dummy PDFs, something like that, which was pre-created for the purpose of our education today. Again, repeating this data can be then it is the real data that you guys are using in everyday jobs that that are serving your processes and everything. So don't just be focused on these few sentences and this dominance of this data. This is just for the educational purposes. Okay, let's jump back here. And what we did through the indexing process, we created this index, and we have here, Search Explorer, which gives us opportunity to search, to write some kind of terms, to write some kind of query phrases, and gives us opportunity to query it. So let's query stuff. Let's see what's happening. For a start, let's query all. You see the wildcard here. Wildcard obviously means give me everything. So this is the look and feel of our index. You can see the content. You can see the title of the file. You can see some kind of internal ID. And you can see that we did some kind of skills. We extracted the key phrases from this. Okay. That gives us opportunity to query by the key phrases as well. We have here the other file. We have here the third file, etc., 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 etc. So let's do the keyword search, since you see that we've been extracting the keywords during the indexing. Let's check for the data. But right now you can see all data that was indexed. It has 15 different kinds of, since we have initially 15 different kinds of PDFs, we have 15 rows with a keywords. Let's just, check for every single data that has water quality monitoring in it. Database is returning us pretty fast, in terms of all. Let's query let's check as well some kind of more complex stuff. We did turn on semantic ranker. We have different kinds of API for the connection. What does it mean? That means that this is as well as the other resources that we checked and the other resources in the last sessions are available via API and via some kind of CLI, so you can integrate it in your Jupyter notebooks or some kind of other workloads in general. Okay, let's do another, some kind of querying of it. It returns, all references to the files and the files that are related to the methods for reducing monitoring costs, etc., 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 etc. I can assure you right now that these files are talking about this. But in general, this is important stuff, the whole process. We have data source. Data source can be trillions of files, petabytes of files in a blob storage or whatever that is. We have full pipe that will index and enrich this data, and we have opportunity then to query this with this semantic or the vector approach in general. Okay.
And of course, all of these queries allow you to kind of essentially show your workings so that when you're actually presenting the final research, you can actually demonstrate, the history of what you searched for and how you looked for it and sources and so forth. So you do have your workings available should you need to go back and check later.
Yeah. You need to think of this particular service as something that will help you to search through the data, not by traditionally writing some kind of SQL joins or thinking in that kind of way. You are just writing the phrases and terms or whatever you like to search your data, which I would say natural language, in general. And this is really helpful for because when you can think of it, you just came to the library and you don't know how library is structured and you don't care, and you just have opportunity to ask the library, I need what happened yesterday in the field of this, and you have opportunity to get the top 10 results of it and to just on this field and just to be focused on this, and the other trillions of the other data which is in a library is not relevant to you. You don't need to know anything about the organization of the library. You don't need to know how to proceed with the question in terms of the writing complex joins or whatever. You have the fully managed, and you have a fully managed resource in Azure that can help you to easily understand the knowledge of it and easily query your knowledge, whatever that knowledge is. So what we build here in the background is this index with enrichment, and we enrich it with the key phrases, entities. We build up this some kind of knowledge store, and we query some kind of full text search, face filtering, semantic ranking. And believe me, setup of all this was nothing that was tremendously difficult to do, and it's just some kind of execution of the CLIs of the setup through the portal. Why is this important? Because you can have some kind of literature review. You're searching by concept, faced by year. You're asking it by the intent or stuff like this. You can build up your own repository, auto-tagged, cross-departmental. I haven't talked about it here because it's out of our today's session, but you can definitely do some kind of really complex hierarchies of the metadata here and do preparation for the AI agents, data management, knowledge stores feeds in a fabric, and you can then reuse it, etc., etc.
I love that concept of it being essentially an expert librarian to help you manage, sort, and find information. And that's a really great analogy there, because I think it's important for those people who aren't actually data management, data experts, to be able to use this to manage the stuff. So that's really interesting. Thank you.
Thanks, Carl. Moving forward, let's talk about the document intelligence, content understanding, what that is and how it's different from the stuff that we've shown until now, and how can this help us. So idea is to have something that can help us to structure data from forms, reports, scans. We can extract data from documents, images, audios, videos. You can do some kind of custom analyzers with schema, multimodal AI powered. And on top of this, once when you do that, you can access it through the REST API or SDK. So you can do it through the Microsoft Foundry project, define some kind of content understanding schema for information to be extracted, and you can build up analyzer based on the completed schema and use an analyzer to extract or generate fields from new content. It's kind of abstract right now. It's going to be clearer when I show the demo. with some kind of predefined analyzer, what we are going to play around with it, you can create your own custom analyzer in a Foundry project, define some kind of schema with fields, define numbers, dates, upload samples, test accuracy. Here on the right side, you can see examples of the real world. You know, why is this important? You have some kind of receipt, you have invoice, business card, which are not, you know, you can imagine which are not the same all around the world. Maybe you have some kind of different on the institutional level as well, invoices that needs to be proceed or stuff like this. You can have opportunity to do this. Document intelligence in general, what does it mean and what it's important? You have pre-built different kinds of options for understanding the data from invoices, receipts, IDs, cards. You have some kind of setup for the general layouts, tables, key values. This is a cool stuff if you have standardized formats of the documents for extraction of the data, scanned PDF reports, ethic forms, field notes. With, you know, after that, with Azure AI search, once when you understand this, maybe the pipeline could be, you know, in general, to process the data, to understand the data from the invoices. You can then index this data in the Azure AI search, where you can, you know, use data from a range of sources. This can be one of the skills in the indexing, which will enrich your data and prepare for the further query. Yeah. Custom document models, has been said, not all documents are the same. I have here notification. Okay, okay. Custom document models, not all documents are the same in the same format. We are talking about opportunity here that you can train your document layout. You know, maybe you have the documents which are in your own standardized format or multiple different kinds of format. Why? Because you want to say to the AI engine that, I don't know, on this particular piece of the document, they can find some relevant ID which is relevant for your institution, and this is important for you, and you can then retrain with the examples those kind of custom models, which is then are used for some kind of custom classification, sorting by type, or, you know, or extracting some kind of data. Let's talk about the broader perspective and some kind of pipe. Maybe you have scan of documents, forms. I believe, and I can imagine from your work that maybe you are sitting on the lots of the legacy documents, which are scans of analog documents, and this needs to be processed, digitalized. Yet just because it's scanned doesn't mean it's digitalized. You need to extract the data and you need to put it somewhere with where it can be useful for you, you know. So you can scan forms, you can put up on top of that content understanding, do some kind of structured JSON on top of it. If you remember the data factory we were talking about, it's an ETL pipe, the technology which can help then import this structured JSON in a Fabric Lakehouse. Why? Because you want to do something with this analysis data. Okay. Comparison, content understanding, document intelligence. What's the difference? Content understanding is a newer stuff. It's you know, multimodal, schema driven. It's the best for custom research, and we have on top of that next to it document intelligence, which is older technology for processing documents, pre-built custom. It's a best for invoices and forms. And we are going to check how this thing is working in a real life. Let me switch to the browser. Okay. Okay, same as for the language studio, you have document intelligence studio and content understanding studio in general, which is nothing else but just some kind of UI that can help you to consume this service, which is available through the API and some kind of CLIs and SDKs integratable, and to play around with it, to try error and to find out what best serves for you. When you jump in the document intelligence studio, let me just, yeah, you can see different kinds of categories where what you can do. You can do OCR read, you can do some kind of layout extraction, you can process general documents, and you can use pre-built models, as been said, invoices of extracting invoice ID, customer details, vendor details, etc., different kinds of receipts and identity documents, US health insurance cards, personal tax, mortgage. This is, obviously pre-trained for the US in general, but you understand the concepts for the data of the European Union as well. Credit cards, business cards, and has been said, some kind of custom models. Okay, let's jump to our demo. So let's go on processing of the general documents. You see here, the guys from the Microsoft gave us some kind of examples of their own, but we are going to drag and drop some of our dummy demo data. Just give me a sec. So for instance, we have here some field analysis report in a PDF file. Okay. Second one, okay, something like that. The idea is that we are going to consume this and trying to understand what is behind. Let's just drag and drop our guy over here. This is our document. Okay. And let's just, without some kind of further calibration, do the magic, run the analysis. Let's check what's going to happen. Okay. What happened in the background? Again, this is just some kind of preview for the user understanding. Result is like this, you're getting from the end API some kind of JSON, which have defined schema. You can then, understand where in the document, you see the polygon, is which kind of content and which kind of confidence, about it. So this is just consume this data for the preview purposes. So you have different kinds of entities that was extracted over here. The whole service understood that we are dealing here with sample, collection date, site name, collector, quality, flag, and field note. You need to understand the difference between the general OCR. General OCR is just extracting the text from the documents. It does not understand the context of it. This particular service is understanding that this text that is extracted, it's some kind of sample ID. It understood the context of the whole document. And it said, oh, okay, yeah, this is the sample ID. And the sample ID is like this. This is the collection date. This is the site name. Why is this cool stuff? Because when we have this standardized approach, we can automate this. We can do processing of such extraction on the general documents or the particular documents that we have on the massive level. And we can, for each this document, get some kind of result, which can then be processed in some kind of bigger pipes, which is the cool stuff. Let's try another example. We have one more dummy lab report. Okay, it's the similar from the structure and everything. Let's run the analysis and try to figure it out what's here happening. Okay, sample ID, collection date, site name, collector, quality flag. So you can, in general, imagine processing of this of the large scale. Once again, to say we are pushing some kind of PDFs or Word or whatever format that is, and we are getting the extracted content that explain us, aha, this text is this business entity. And I'm certain for 94% that that's the case. Okay. So that's the document intelligence studio. So you can imagine, just to repeat the broader picture, that output is structured JSON and data factory pipeline can call this document intelligence API, send each scanned report, receive the extracted field, load them into some kind of data table in the lakehouse, and physical documents become queryable research data by me. You can then just have reference for it, and you can understand that, okay, in this particular PDF, we have site, it's related to this site name, and we can then easily found and ask with query on this particular site which kind of data has been measured in last quarter, which is a cool stuff. Okay, guys, do you have questions for this particular piece of technology? Just to recap what we saw, we have some kind of document fields analyzer. We extracted different kinds of data, sample ID, date, site, pH, processed several of files, and we extract the structured JSON with the confidence scores and ready to integration with notebooks or whatever. This replaces manual data entry for sure.
Yeah, Mary, you say that it's been trained. I mean, obviously, a lot of it's been trained on American formats and so forth. What is the process of training? Do you presumably just put in lots of documents and it makes guesses, and you have to then correct it and correct its errors? Is that a relatively complex process?
You're referring to some kind of custom extraction and stuff like this. So,
well, if you're giving it documents that it has never seen before, then it will need training presumably on those documents.
There is a documentation Microsoft is requiring. In general, it's easy because you need to build up some kind of metadata annotation with the data that you're going to give to it, and there's some kind of format in which you need to annotate the data, metadata about the real data that you're going to set as a training data source, and you don't need to manage about and think about anything. It's a full managed. You just upload it. You can do it here through the portal, upload the data, or you can do it through the CLI and point to the storage or whatever. And everything is fully managed by Microsoft. They are provisioning some kind of hardware and the infrastructure in the background, which is going to be used for the retraining and for the hosting of this model. So it's not a complex thing. It's not a complex thing to do. So you have the standardized some kind of format which can be checked in the official documentation, and some kind of which needs to be built up from the training data set, and you're uploading this and giving everything else to the backend services to create your own model.
Yeah, I was just thinking that way back in my that I used to work for Jaguar Cars, and I used to manage part of their archives, and obviously they have huge archives of all of their sales records for very old vintage cars, and the format of those documents is unique to Jaguar Cars and has never been seen anywhere else and never will be seen again. So presumably you would have to train a system to say, when I'm uploading all of that data, this is where the information is, this is the dealer name, this is the customer name, and so on. I would have to go through the process of the first time training that process.
In general, my recommendation is, to use some kind of smaller subset of data and to test the current models, because models are I would say, pretty intuitive. They're not
Okay.
related. They're not related to particular position of the data or particular entity. They are pretty intuitive to understand, where the data is, and to understand from the context of the whole file what data are we talking about here. Because in this example that I just showed, this is not a custom model. No, this is the dummy data that was generated for the purpose of this education, and it was just pushed into general model. And this general model can cover lots of different kinds of variations and scenarios. But if you are not satisfied with the end results, you have opportunity, to fine tune this and to build your own custom model on top of this layer.
Yeah, no. I was just clarifying there because obviously we're talking like historical data, that will be in, formats that have changed over time. I mean, because some of that data will actually have, non decimal currency on them, in fact. And so therefore the systems would just go, what the hell are pounds, shillings, and pence? And so there would need to be some training on that. I'm just thinking about, you know, any kind of researchers who are maybe trying to use current data and historical data, and how to they would need to train the systems to understand the correlations between the historical data and the current data and so on and so forth. I'm just sort of like
Yeah.
thinking on my feet
Yes.
here, basically. Yeah.
So in general, the best approach is, through all these set of sessions, we try to cover the whole portfolio of different kinds of services,
Yeah.
and these services are, interconnected one to another, and we are not talking about isolated islands. Maybe you will, for the certain subset of data, be happy with this general model here. Maybe for the other subset, you will be happy for the custom model. Maybe for the third, you will need to, if you remember from the last session, we have Azure AI Foundry. There is more than 11,000 different kinds of models available over there, and you can use those models as well for document understanding and stuff like this. So it's important to understand that you're not tied and related only to the one particular service. You have portfolio of different kinds of stuff, which can help you in on different kinds of journey pieces of your whole workload. You in the real production overloads, you will combine all this. This is something that I can say to you from my experience from the real production.
No. This isn't meant as a criticism. It's just meant as a kind of I kind of had the light bulb moment, and I was just wanting to share the light bulb moment with a couple
Yeah. Of course, of course, of course,
yeah,
of
cool,
course.
fantastic. Sorry, carry on. Yeah.
Thanks. Moving forward, let's talk about multimodal AI for the research. What does it mean? Research data is not just, plain text. It's not structured text. We know that. We have diagrams. We have some kind of images. We have lots of the stuff. But it's important to understand that we have opportunity to do understanding of these types of the data as well. So let's just mention, that we have opportunity to have image analysis for the research. What does it mean? You can think of, I already said, some kind of big archive of the images, and you need to classify it, and you need to do some kind of with this data. And it was heavy to do this manually before. Right now, you have technology which can help you in caption tagging and object detection, dense captioning, biodiversity, archaeology, talking about some kind of satellite imagery, lab images, whatever that is. What does it mean? You have some kind of image analysis client. You can just, do initialization of this analyze method that is going be connected to the vision service and process all those images. The same approach like we did for text. The output is some kind of JSON, which gives you lots of the metadata for understanding what is on the image, where is positioned, etc., etc., etc. And then you can integrate this output JSON in your next workload. OCR, we mentioned already that we have here support for it. We are reading text from images, scan doc signs, readings, handwritten field notes, positioning per word. It's more than 120 languages supported. So in general, why is this important stuff from the perspective of the multimodal? Because some kind of generative AI models are responding to the prompts, returning dynamically created content, and these models can process prompts that contain text, speech, images, and this is why we are saying those models are multimodal. That's bringing back to our discussion, last discussion, Carl. You have opportunity to use not only those kind of types of services. You can provision some kind of custom model or large language model for foundation model in the Azure AI Foundry that will help you to understand the content of the document that is containing the text and the image and everything. So multimodal, you can think of the vision, language stuff, not just that, audio processing of the videos. Maybe this is why we're talking about the multimodal stuff here. Images, text in a single prompt using some kind of models like GPT 4.0, 4.1, 5, which can then describe geological features, compare images, and you can then store those projections and everything in the storage or whatever that you want to do. You see that I'm, in different kinds of examples, I'm trying to just, not to narrow the whole pipe, the whole workflow. I'm just trying to, give you the whole portfolio of services, everything that we did until so, and give you, insights that you can combine all those nice features of the services together to that are, in general, to your workflow and are supporting you there. Okay. Vision, when we're talking about why do you want to use this vision services or multimodal models or whatever, why? Because you want to have some kind of images, camera traps are tagged, you want to use the data of the GPS and do all this on the batch level. You want maybe in archaeology, do metadata of your catalog and OCR the labels. Maybe in the field of environment, do some kind of satellite imagery, algae blooms or whatever. Again, combining services, language, AI search skills, vision, Foundry with some kind of additional models, etc., 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 storing into Lakehouse for the further processing. On every single step of this, you are extracting just one tiny piece of the information, entities, sentiment, indexing, store, images, forms, whatever that is. And that brings us to the end-to-end architecture. What does it mean? In our 4 sessions, we've been talking about different kinds of aspects. And again, I want you to think about not isolated service by service, but how to combine this to help you in your workloads. We have data platform from Fabric, OneLake, some kind of notebooks that with for examining, for understanding the data, categorizing data. On top of that, we are building, we saw last time, Foundry agents, which can help us to talk with the data in natural language, which can help us to provision more than 11,000 different kinds of models for different kinds of purposes. Vision understanding, speech understanding, text understanding, and the other way around. Today, we saw a small glimpse of the other services like language, vision, search, which can help us to enhance the data, to understand in which language that is, to understand what entities do we have in our data, how is this correlated? Are we talking about some kind of person data, that needs to be protected, And after that, how are we going to leverage it? How are we going to build up the knowledge base that can help us to build up our own quick, fast, searchable endpoint for our workloads? And on top of this, we have some kind of, outputs from our system that needs to be, you know, uh, designed for you guys for the research to understand what is with your data and how you can benefit from your data and do some kind of decisions after it. You have lots of here stuff to learn on, lots of the stuff to cover additionally. 2 hours are not too much time to show you all those possibilities, even from those 3 services that we covered today, but you need to think broadly. This is why we're talking about architecture. You can go to certify yourselves, you can Google this kind of stuff, and you can understand how to go. There is a lots of free content on the Microsoft Learn that can help you to understand, to go deeper in analysis, how to analyze text, AI search solutions, document intelligence, image analysis, building AI agents. And you have different kinds of GitHub labs which are available, so you can play around with it. I already mentioned that for the researching institutions, there is some kind of granting and credits. You can take advantage of it and to play around with this technology for free that Microsoft is giving you. So GitHub Labs for today's session, you have text analytics. Just Google this and full link is going to be shown to you. Info extraction, vision, and AI search. Moving forward, before we just give some space for you guys for the questions, let's just mention that we have next session, fifth session, where we're going to talk about some kind of R&D experimental design in the machine learning for research. We're going to tackle for Azure ML workspace, different kinds of aspects over here that is going to fill the additional gaps in our whole ecosystem, in our whole portfolio. We've been talking about how to use AI, how to leverage the existing models, how to fine-tune stuff, how to automate all this stuff. And now we're going to dig deeper into machine learning, how we can, proceed with our own models, how to build up the models, how to retrain them, how to publish them, how to build up them in a whole workload that we learned in these 4 sessions. Guys, I'm open to your questions before finishing everything.
Great. Thank you, Mira. That's absolutely brilliant. Thank you so much. Yes, the floor is open to anybody for any questions. So if anyone's had any light bulb moments over the last hour and a bit, fire away and ask away.
Nothing. Okay.
Nothing at all. Okay, that's great.
Right.
Well,
Yeah.
thank you all. As I say, the session will be is recorded, so it will be available to you to go back on later. Thank you very much, and also to share with your colleagues, because please do share with your colleagues to find out who else is interested in this kind of things. But once again, Mario, thank you so much for your time, and I look forward to the next session in a couple of weeks' time.
Thank you very much, Carl. Thank you, guys, and see you soon. Yeah.
Thank you then. Take care all.
Yeah, thank you.